purpose of this lesson is to learn how and understand how to write the equation of a line. If you recall, and as we talked about in class, a line is made up of an infinite number of points. However, we only need 2 points to write the equation of a line. And when we talk about the equation of a line, we're talking about identifying two distinct aspects of a line that is unique to each line. But before getting into what we're going to cover, let's take a look at the do now. How do we know if the coordinate 3, 2 is a solution to the equation given? Well, similar to other work we've done before, 3, 2 is an x and a y value. So all we are asking is when you substitute in for x and y, does the equation hold true? And the answer is yes, it is. Now, when we talk about the slope of a line, what we are talking about from a math standpoint is a number, since it's math, we use numbers, that represents the measure of a line's steepness. So we can put an actual numerical value on a line that tells us how steep it is. And one of the words, or a couple of words that we use to help us with this, is that it's the rise over the run. Rise is associated with the y value, run is associated with the x value. The concept of slope is very similar to gradient that you've used, or many of you have used in science. So there's actually a very simple formula to figure out the slope of a line. And m, lowercase m in script, is the symbol for slope. And the slope of a line is what's called y2 minus y1 divided by x2 minus x1. These are not exponents. They are notations to tell us that we're using two separate y values and two separate x values. This little formula will now give us the numerical value that will tell us how steep a line is. So going to, sorry about that, the 4 examples here, I want to compute the slope of the line that goes through the particular 2 points. If it helps you, you can label x1, y1, x2, y2 your coordinates. Don't have to do that, but it's something sometimes students find helpful. So I'm doing 5 minus 2 over 3 minus a negative 1. So my slope is 3/4. I'm not going to go through it, but just to remind you, I did this in class. If I switch the order between both pairs, not one, I get the same answer. Okay? So for the next one, negative 2 minus 4 over 3 minus 1, which is negative 6 over 2, which is a slope of negative 3. Always try to reduce the fraction that you get into simplest form. And always keep the fraction as a fraction. Don't convert it to its decimal equivalent. Okay. Next one, m equals 5 minus 5 over negative 4 minus 2, which is equal to 0 over negative 6. That is a slope of 0. As we talked about in class, a perfectly horizontal line has a 0 slope because if I put an object on it, it would not go anywhere. Okay? And then the last one, I have 3 minus negative 2 over 4 minus 4, which is 5 over 0. You should recall from earlier lessons that 0 in the denominator is undefined. So we say the slope is undefined, not it's no slope, it's an undefined. That, as we talked about in class, would be a vertical line because if we tried to put an object on it, it wouldn't roll, it would fall off. Okay? Now, let's take a look at figuring out slope in another situation. I give you the line itself with 3 points on it. Now, most people's inclination is to take 2 of the points and do the calculation we just did above. But it's actually much simpler than that. How do I go from 1 point to the next? Well, I moved 1 unit to the right, so that's a positive 1. 2 units up, that's a positive 2. So the rise is 2, the run is 1, and I'm done. I don't have to do the subtraction that you did earlier. Now, lines can have a positive or a negative slope. Positive slope is when the line goes up to the right, as our example is over here. A negative slope, excuse me, is when it goes down to the right, something like that. Okay? You can change this around to be down to the left or up to the left. Doesn't matter. It works either way. Okay? Now, I'm going to erase what I wrote here so we can get to the next thing. So, slope is not a coordinate. All it just tells us is how steep a line is. Next is this concept of y-intercept. And as we talked about in class, the y-intercept means where does a line intersect the y-axis? Well, in this example above, it intersects it at the point 3. So the definition of the y-intercept is the y-coordinate of the point where a line intersects the y-axis. And as we talked about in class, every point on this y-axis, every point, and unfortunately my orientation's off, so can't get there. I got to go that way a little bit. Okay. Every point on that has an x-coordinate of 0. Okay. So now we want to get to what is the equation of a line. That's what the whole point of this lesson is. Well, if you think about the following, it'll hopefully make some sense. As we said earlier, as I said at the beginning, a line has an infinite number of points, but every line has only one slope and one y-intercept. There's only one level of steepness, and it can only intersect the y-axis at one place. So those two elements are critical, and that's why we have what's called the slope-intercept form of a line, and the form is y equals mx plus b, where m, as we said before, is the slope, and b is the y-intercept. So now let's get to writing the equation of a line. The first are as straightforward as I've written them. I give you the slope, I give you the y-intercept. That's it. Okay? I need the x and the y in my equation because they're placeholders for the multitude of coordinates that go on that line. Now, I want to write it when I give you the line as a graph. Well, let's do the easy part first. It's y equals, my y-intercept here is 1, so I know it's plus 1. Now I have to figure out the slope. Well, to go from this point to the point up here, I go to the right 2 and up 4. So what's that slope? 4 over 2, or 2. 2x plus 1. Next example, y-intercept is a 2. So it's something plus 2. And then to go from one point to the next, and it doesn't matter which 2 points you choose, you just want to make sure you're choosing points that have integer coordinates. I'm going down 1, that's a minus, to the right 2, so that slope is a negative 1/2 x plus 2. Okay? Now, let's say I give you a point on the line and the slope of the line. Well, you clearly should be able to write part of the equation, and that part being y equals 3x plus b, because I tell you the slope is 3. The problem is I don't know what b is, and I can't figure out b because I have b, x, and y. I have 3 unknowns. However, this is an x, and that is a y. So I can substitute them in, and now I could figure out that b is negative 1, and I can complete the equation. Same thing here. Now I substitute in. Coincidentally, b is negative 1 again. And I can write, whoa, that kind of moved on me there. I can write my equation. Now, last step. Suppose I give you 2 points and I want the equation of a line. So one of the classes we got to this, the other class we didn't, but we did identify the first step. So what would be the steps? Step 1, find slope of the line using y2 minus y1 over x2 minus x1. Okay. Step 2, substitute the value for m found in 1 and any of the 2 points in for x and y. Step 3, solve for b. And step 4, write the equation in y equals mx plus b form with a value in for m and b. Okay. Now, we're going to walk through 3 examples of this following our steps. Okay. So, step 1, I'm going to figure out the slope. 1 minus negative 3 over 2, negative 2 minus 2, which is 4 over negative 4, which is negative 1. Step 2, I can now put in, I have a choice. I can use this or that. I don't need both. So I have my y equals mx plus b. I'm going to put negative 3 in for y. I'm going to put negative 1 in for m. I'm going to put 2 in for x. And I don't know b. Step 3, well, step 2 and step 3 is now I'm just going to solve. That's a negative 2. So b equals negative 1. And step 4, I complete my equation. Okay? Negative 1 is both the slope and negative 1 is the y-intercept. Remember, slope is not a coordinate. It's just measuring steepness. Y-intercept is a coordinate. Okay? All right, let's continue with the next two, and I promise you -1 will not be the y-intercept for either of these two. So I determine what my slope is. 2 minus -13. Please be careful of your signs. 4 minus a -8. 15 over 12. Simplify it to 5/4. I now want to substitute in y equals 5 over 4x plus b. I want to choose which of these two coordinates is easier for me to work with. The smaller numbers are usually easier. Okay, 5 over 4 times 4 is 5. So b is -3. So my final answer, y equals 5/4 x minus 3. And then the final example, slope, -17 minus 3, 19 minus 9, -20 over 10, which is a -2. Start with my equation, substitute in one of the pairs. I get b to be positive 21. So I have a final answer of y equals -2x plus 21. So to recap the lesson, our objective was to come up with the equation of a line given various pieces of information. What was most important for us to figure out were the slope, which tells us the steepness of the line, and the y-intercept, which tells us where the line intersects the y-axis. Once we have those two pieces of information, we can then write the equation of our line in what's called slope-intercept form, y equals mx plus b.